Hi, my name is Carl Lohler, and I'm joined today with Tony Kaplan and Nick Mowry. We are going to present to you our multimodal scene access system. Our agenda today is first we're going to introduce our problem statement. We're going to talk about the persona of our primary user. We will outline our multimodal beacon system that we intend to implement. We'll demonstrate our application interface, how our indoor positioning system will work to provide orientation for our users, and then we'll do some quick walkthrough demonstrations to show how our system will work. So our problem statement is, in what ways can we improve the user experience for blind or visually impaired customers at hotels by designing a multimodal scene access system to deliver environmental perceptions and awareness of their surroundings. So our problem statement was inspired by an episode of This American Life where a gentleman traveling for business got confused within his guest suite and was unable to find the telephone because there were a mirrored image of the hotel room. So when he checked one side, he assumed the other side was similar, but it was in fact different, and one side had a telephone and the other side did not. I highly recommend checking out this episode that I've linked here on this slide. Moving forward, our goals and challenges that we have with our system. So our goal is to describe the scene of typical hotel. All hotels have certain things like a main lobby, corridors, and of course they have guest suites. The trouble is not all hotels have the same floor plan or are laid out the same, as demonstrated by the This American Life episode. To determine what challenges are typically faced by visually impaired travelers, we reached out to Mind's Eye Travel as a company providing travel services for blind and visually impaired, and they put us in touch with a gentleman by the name of Jim Alberti. He is a frequent customer of theirs, so we contacted him and did an interview with him to find out what sort of challenges he has and what recommendations he might have for our system. One of his biggest concerns was that we were overthinking the system. He told us to keep it simple and focus on the basics and do the basics well. So we took that advice in building our system. He also mentioned that one of his biggest challenges, while he manages to get around pretty well just in his day-to-day life, and traveling to hotels is not much different, but one of the challenges he struggles with is, for example, coming out of an elevator. He does not know which direction to turn for his row of guest suites. Similar, likewise for the hotel lobby. When you arrive and you're not really sure where the front desk is located. If time were not an object, or it was not a constraint of ours, we would have certainly interviewed more people because that information proves to be very helpful in designing our system. So based on our learnings from Jim, or Mr. Alberti, the persona of our primary user will be someone who is visually impaired. There will be a frequent traveler, someone who's comfortable getting around their day-to-day life using a service dog or just their own senses to be aware of their surroundings. The user should be comfortable using technology. Our application will run on a smartphone or mobile device, so the user will need to possess one of those. The user will also need to be capable of hearing audio signals at a reasonable level. The reason for this is the interface of our device or our system utilizes text to voice as an aid as part of our multimodal system. And we also use some haptic feedback, so the user will need to be able to utilize a reasonable amount of dexterity and haptic perception. So our system is built around GeoFencing technology. GeoFencing is a system that uses Wi-Fi or Bluetooth to set up a virtual zone, and it pushes informative notifications to users as they enter that zone. So we shopped around and looked at several geofencing systems They're currently in use, and we found this company, SIE Lab, out of Sweden, to have a very robust system. Typically, their geomessaging system utilizes beacons strategically placed, and they're typically used to relay omni-channel marketing information. So as a person at a shopping mall, say, as a person enters that zone, stores can say, hey, we have a sale on this product. Come on into our store. So it's a way to reach customers using this geomessaging technology. The SIE Lab system does interface with a smartphone application, so users have to set up the application before the system will send them notifications as they enter the geofencing zones. One of the things we liked about the SIE Lab system is they have a full beacon management database API system that makes it easy for programming the beacons and controlling the push notifications, and gives you a full health of the system. It'll let you know if beacons are low on battery or if they're malfunctioning in any way. So it seemed like a really strong system. So our intent is to utilize their system, but make several enhancements to adapt it to our needs to create a full multimodal scene access system. So we are going to modify the smartphone interface to include many more multimodal features. Currently, the SIE Lab system relies purely on visual cues or channels to receive the messages. I've pictured here on the right a SIE Lab beacon. They're not very big. They're about 2 inches by 4 inches and about 1.5 inches deep. What we would like to do is modify this beacon, making it maybe twice the size to add two-way signal capabilities so that we can send information to the beacon as well as receive information from the beacon. In doing this, this will allow us to also include a small speaker, which will be able to provide users with directional audio cue through the smartphone interface. So how that'll work is the user will press a button on the phone, which will activate a subtle yet effective audio tone to orient the user in the direction of whichever beacon they requested the directional audio from. Having multiple beacons will also allow us to use indoor positioning techniques to orient the user for directional purposes. We will be able to accomplish this using a system known as dead reckoning that triangulates the position, and we'll be talking more about that later. Finally, we would also like to utilize these or modify these beacons in order to connect them to a database that allows them to use image recognition technology, which will be useful in the guest suite itself in order to locate specific items within the guest suite. So our hotel beacon application that we'll create will be available for Android and iOS operating systems. And once we launch our product, you'll be able to find us at www.hotelbeacon.com, where we'll have a interactive website set up that will inform users with a list of all participating hotels. We'll have instructions on how to download and install the app on your mobile device. Our website will also be where we'll keep our collection of crowdsourced user feedback to give us an idea of what items we can improve on or what items users tend to have trouble with. And you can also add to this because we will have a suggestion box where users can petition for enhancements or just generally give us feedback about how our Hotel Beacon application works. One of the key elements the users will be able to obtain at our website will be pre-journey information and maps for the user that will be available both in traditional floor plan maps as well as descriptive verbal maps. The user can visit our website before they arrive at the hotel and really kind of take a virtual tour of the hotel, and get the fundamental layout of the lobby, what the guest suite will look like. And this will help our users to utilize recognition and recall memory when the time comes when they're interacting with our interface. So Tony will be up next to talk about the interface.
And I'll be going through an overview of our interface. We've divided the phone screen into 4 quadrants. At the center of the 4 quadrants is a call for assistance button, which will be constant throughout the application. At any time, users will be able to call for assistance. Users press and hold this button to make a call. It will prompt them to continue holding to make the call. If they do so, the call will be made. They can hang up through a similar means. This is designed to help prevent users from accidentally calling for assistance or unintentionally hanging up during a call. While this button is constant, the contents and function of the 4 quadrants will change depending upon what options are available. The default for our application includes the colors blue, yellow, red, and green, one for each quadrant, and white text with a black outline, that way it's visible on any color. Users will be able to enter settings to change the colors available. The color options are completely customizable, but we will have a few built-in options for different types of color blindness, such as for those with red cone cells defective, green cone cells defective, or blue cone cells defective. Users will also be able to change the text size or invert the colors to black text with a white outline rather than white text with a black outline. Although the options in the quadrants change depending upon what options are available in the application at the time, we do have a few consistent gestures that are always available. If users encounter a new beacon, they can at any time swipe up for directional information. They can swipe down for settings, press and hold the center of the screen to call for assistance, swipe right to repeat options, or swipe left to return to the previous menu. These options are read out at the end of each menu. We were worried this may annoy some users, but in fact, they will only encounter these options had they not made a selection earlier. Because these options are available at any time, users will be able to swipe left to return to a previous menu if they've gone somewhere accidentally. Or, if they've missed the beginning of a menu, they can swipe right to repeat the options from the beginning. While those options are consistent, the contents of the 4 quadrants will change. For example, each time you enter a new beacon zone, they will refresh to the different options available with that beacon. For example, a lobby beacon would have different options than, for example, a room beacon. So each possible location or action will be listed in the quadrants, but they will also be read off in the menu, so the users can either click the quadrant or swipe up when it's read off to select that option. Nick will now go over some other aspects of our device, including its use of dead reckoning and a more specific overview of the settings available.
Dead reckoning. Dead reckoning is not a new concept. Humans have been using these types of calculation for millennia to provide navigation to a destination that is not directly visible from intermediate points of travel. Here, we have adapted it to help provide orientation for users in an unfamiliar scene when not in close proximity to one of our beacons. Given the location of one of these beacons, an angular offset from the desired path to this location, simple trigonometry will determine the direction the user needs to travel to arrive at their desired location. While the user makes their way to this destination, dead reckoning can be used to continually evaluate the user's changing velocity and angular orientation compared to the desired path, and provide a new heading to keep them traveling toward the desired location. Drawing velocity and orientation from the user's smart device, the current location can be roughly calculated to keep track of the user's bearings. This information will be pulled by the beacons in order to give the user correct directional cues, whether it be to destinations such as the lobby and elevators, or the location of a thermostat within the guest suite. As the user moves toward either the destination or the next beacon along their path, the device will alert the user when their device is oriented in the right direction. Options for this alert will be haptic to provide a series of vibrations, auditory feedback from the device, beacon, or both, and visual indication, fading the black center button to white when the device is aligned with the correct path. Settings menu. Within the menu system, the user will be able to control interface modality as well as view and contribute to online user content. To access the modality settings, the user taps the appropriate quadrant of the screen. In this case, reading across then down, the options are audio settings, haptic settings, visual settings, and user feedback. To provide a consistent interface, these menu options are, by default, provided as text-to-speech audio output. For example, the user is able to increase the text-to-speech playback by first clicking on the top left quadrant of the screen to access the audio settings. Options on this screen are beacon sound settings, device sound settings, text-to-speech, and voice recognition. By tapping the bottom left quadrant labeled text-to-speech, this will allow the user to modify these settings. Here, the options are speech speed, speech volume, speech pitch, and speech delay time. Selected will be speech speed. Here, the upper left and right quadrants, represented as a plus and minus sign respectively, can be pressed to play an example text at faster or slower speed. If the user cancels or swipes down to exit this portion of the menu, they will be alerted that changes made were not saved. Conversely, saving changes alerts them of this and returns the user to the previous menu. In a similar way, the user can change visual settings, beacon settings, and access reviews and tips from the hotel's previous guests. Regardless of what the user accesses, if any changes were made while in the settings menu, a final set of options will ask for confirmation. This will help prevent a blind user from inadvertently turning off text-to-speech, thereby forcing them to rely solely on recall to navigate through the menu system to rectify the situation.
So now we will demonstrate a quick walkthrough using our Hotel Beacon app. Presumably when a customer arrives, they'll be arriving at the main entrance where they will encounter their first beacon, which will give them a message alert to their mobile device. It'll arrive similar to a text message where your phone will either vibrate or deliver a ringtone to alert you of the message, and a message will appear on your screen saying, "Welcome to the hotel." So when the user presses on their screen, the app will engage and take them to the main menu for the lobby, their immediate scene around them. The main menu will give them the option to, well, actually it'll read them the available scenes within the lobby in the order of top left for front desk. It'll say press the top right for guest suite, press the bottom left for the restroom, press the bottom right for the stairs or elevator. So the user will have the option of selecting one of these four quadrants, and at any time there will always be the call for assistance button will be in the center of the screen. So the menu will also read to the user, swipe up for directional audio, swipe down for more options, or press and hold the center to call for assistance. So if the user wants to find the front desk, they would select the top left quadrant of their phone by pressing in that area, and a message would be read to the user through text to speech saying the front desk is located to your right. Likewise, if they were looking for the restroom and pressed the lower left, the interface would say the restroom is located to the left. Should the user, depending on which way they're facing, left and right could be difficult to interpret. So to better orientate themselves, the user has the option to swipe for directional audio. If the user selects the front desk, a digital audio will sound at the beacon located at the front desk. This signal will be non-offensive. It'll occur in just a short burst, enough to give the user at least a directional idea of where the front desk is located. To maximize use of this audio signal, it will be a mixed frequency signal ranging from the 1 to 3 kilohertz in frequency, which is the sweet spot for maximum sensitivity in hearing for most people. And the trouble with that, though, is it doesn't give you very good directional indication within that frequency. So we'll also add a component that is in the 5 kilohertz range, which will provide much better directional awareness.
I'll now go through a brief overview of how someone will use this device upon leaving the lobby and entering a corridor. When they encounter a new beacon, their phone will vibrate and send a notification. This can help users who aren't necessarily holding their phone but have it in their pocket know that they've encountered a new beacon, and they should take it out. The application would read off the name of the beacon. For example, this one would read, entering first floor east corridor. It would then read off the static menu options. Swipe up for directional information, swipe down for settings, hold center of the screen to call for assistance, swipe right to repeat options, and swipe left to return to the previous menu. If they wanted to receive directions to a certain location, they could swipe up, and remember, they don't have to listen to this whole menu. They can swipe up at any time. So let's assume they've swiped up for directional information. It would read off directional information, just so they could be sure that the phone had recognized the gesture. It would then begin reading the options for the 4 quadrants. In this case, it would say click top left for directions to room 100 through 112, click top right for directions to rooms 113 through 130, click bottom right for directions to the elevator, and click left for directions to the front desk. Let's say our user clicked bottom left and selected the elevator. The phone would then read directions to elevator, again to confirm to the user that their action had been recognized. If this was the incorrect action, they could always swipe left to return to the previous screen. Had they not selected elevator or any of the above options, the phone would continue to read the static options menu. Swipe down for settings, hold the center of the screen for assistance, swipe right to repeat options, and swipe left to return to the previous menu. Once they have selected the elevator, the phone will then read swipe up to toggle audio signal beacon. At any point on the screen, they can swipe up and an audio signal will emit from the elevator, the option they had selected. They can swipe up again to turn it off. Or if they exit the screen by going back to another menu or exiting the application, the audio signal will also turn off. If the user has not selected directional audio signal, the phone will begin to read the directions to the elevator. First, they will say the elevator is straight ahead and to the right. This is to give the user an idea of where the elevator is in relation to them in simple terms. Then it will be more specific. Proceed 20 steps forward, then turn right. You will encounter a beacon. This is the case because there's a beacon at the elevator that gives them information as to its operation. This beacon could also be modified to indicate whether the elevator is out of order and then offer directions to the stairs. If the user missed these directions, remember they can always swipe right at any time to repeat options. Let's assume they used the elevator and went to the second floor. They would then encounter the second floor elevator beacon. This would have more directional options, such as directions to room 200 through 210, 211 through 220, the gym and ice machine, which are also on the second floor. The menu would then read off, click top left for rooms 200 through 210, click top right for rooms 211 through 220, click bottom left for the gym, click bottom right for the ice machine. Let's assume our user is looking for room 205, so they click the top left. The application would then read off directions to rooms 200 through 212 to confirm their action. They'd once again have the swipe up to activate audio signal beacon option. Then it would begin with the instructions for how to navigate to these rooms. It would mention that odd number rooms are on the left and even number rooms are on the right. So in this case, looking for 205, our user would know that their room is on the left. As they walk down the hallway, they'll encounter other signal beacons. These are the beacons placed at the door to each room that can provide the guest suite information. But using dead reckoning, we can determine that they're in the hallway and they should receive information about the room number. So as they walk down the hall, these rooms will simply read off with their suite number so that users can easily find the room they're looking for. Nick will now go over how someone would use this application inside the guest suite.
The guest suite. As the user enters the suite, communication will begin with the beacon placed at the entrance. In the case of the example room shown here, the bathroom is at the opposite corner of the suite from the entrance. Another beacon will be placed at this door. A guest suite in a typical hotel will have a minimum of 2 beacons, though more can be added to accommodate for larger spaces. The user will have the following options listed across and down in the 4 quadrants of the smart device screen: room layout, sound beacon, locate item, and identify item. By selecting the room layout option, the user will be given brief instructions on how to use the layout feature. Meanwhile, a scaled version of the room's layout will appear on the screen automatically centered on the user's location. Walls and doors will be displayed as thick black lines on a white background. Objects of interest will be line drawn, and as the user moves a single finger across the screen, feedback regarding wall and object placement will be offered. Sliding 2 fingers across the screen allows the user to move the map, and 3 or more fingers touching the screen will return the user to the guest suite menu. Since this interface makes changes to the application's standard gestures, a lack of touch input for 15 seconds will prompt the user to double tap the screen to continue, otherwise returning them to the guest suite menu. By selecting Sound Beacon, the user can choose to play an audio icon through one of the suite's 2 beacons. If the user chooses to locate something in the room, it can be selected from commonly queried items and locations. This list will be sorted with the most common ones shown first. Directions to the items and locations listed will be delivered employing the same methods used to provide orientation in the lobby and corridors. If the user chooses to identify an object, they can do so by holding the device up to the item in question, and the application will then attempt to identify it through use of the device's camera. If the object cannot be found in the local repository of known convenience items such as lotion, conditioner, and shampoo, the app will draw on pictures uploaded from previous users' queries. If still no match is found, it will search for a match on the internet. Failing these methods, it will attempt to use the optical character recognition on the image. All these methods will be seamless to the user, who will simply point the device at the object they wish to identify. Once the object is identified, the object name will be conveyed according to the settings chosen by the user, whether it is briefly displayed on the screen, showed in large, high-contrast font, or given by text-to-speech. By using high visibility display on the room's thermostat, the application can be trained by hotel staff to read the current and set temperatures for the room. Objects can also be given longer alt text titles if important usage instructions are needed to be included. Iterations of this could be applied to the functionality of a shower or the button placement of a television remote control. If the object is a document, such as room service menu or television channel listing, the application will give brief instructions regarding playback, followed by a reading of the provided text. Overview. Driven by the needs of the blind and visually impaired community, This project has been an attempt to provide this group of users the ability to gather scene information in the least invasive way, with no additional equipment requirement of the users beyond their own smart devices. As a starting point, the solution was applied to a hotel environment. This particular scenario was chosen based on the inherent challenges associated with finding one's way in a new hotel. By soliciting input from members of the blind and visually impaired community, we were better able to assume the proper mindset while addressing the perspectives and challenges of being in an unfamiliar place without the aid of sight. This allowed us to gauge a user's expectations regarding any potential solution. In the process of delivering scene information using static beacons and the user's dynamic position, the principles of universal design were made paramount. Among these were the consistency within the interface, as well as error correction, both in the smartphone application, as well as for guiding the users around the various hotel spaces. All of these principles were the framework for a set of standard installation options with the further ability to customize modality and aspects therein. From the lobby to the corridors to the guest suites, the user was given the ability to gather information about their surroundings in a way that best suited their needs. Such needs are not unique to hotels. The solution could be modified to almost any other space to make it more accessible for people through the spectrum of the blind and visually impaired community. Despite the commercial origins of the beacons used as transceivers in the solution, the aim of this application is to provide a service, not necessarily a sale. By modifying the standard beacon, we have also opened up new avenues for providing more interactions for users with visual impairment in places like hospitals, offices, and schools. Having modified the interface of these standard beacons from being purely data transmitters to transceivers with added audio output, the opportunities to evolve this technology is largely unexplored. By continually collecting data from the way users apply this application to their direct feedback, the future iterations would likely become even more in tune with future users' needs and expectations. Carl Lohler, Tony Kaplan, and me, Nick Mowry, we would like to thank the students of SIE 515 for your time and thoughtful feedback throughout this project. Special thanks to Dr. Giudici and Jim Alberti of Blind's Eye Travel, without whose insight into the lives of blind and visually impaired, this project would have been purely speculative. Thank you.